Hello, grade 7. Today we're moving on to a problem-solving lesson. It's not the most typical problem-solving lesson. Essentially what we're going to do is I'm going to work through one problem with you, and then you're going to work through, I think it's about 7 questions on the lesson, but it all relates to the same idea. So, speaking of idea, remember idea? I'm sure you're all silently, maybe not even silently, you're all groaning right now. Guess what? We're not going to use idea today because it just doesn't quite work for this type of problem solving. But that doesn't mean that you shouldn't be actively thinking while you problem solve. So you can't just assume that you're going to use exactly what you used in yesterday's lesson in order to find the answer. You have to really think and ask yourself questions as to what the problem's actually asking you. So you don't need to write out idea, but it is a good idea to think about what am I actually being asked and what can I use to solve that. So I'm going to work through the check your understanding example that's on the bottom of the left-hand page for lesson 11.7. So here we have a set of Scrabble tiles on the left over here. Okay, and it gives you a breakdown. So it tells you, for example, the letter A, there's 9 tiles that are the letter A, and then so on. So what I've done, I've actually added it up, and I've noticed that there are 100 tiles in this Scrabble set. So now I'm going to work through a few different questions about those tiles. So I'm going to be thinking, is this a compound event? Is it an independent event? Is it an independent event? So it says here, if Casey draws one tile, what's the probability of drawing an X, Y, or Z? So the first thing I notice is the word or, and that's not telling me that she needs to draw an X and a Y and a Z. It's just saying, what's the chance that she pulls one of those 3 letters, okay? So this is actually a mutually exclusive event, back from a lesson 11.5, because those events cannot happen at the same time. So pretend she's reaching into a bag, she pulls out one letter. What's the chance that that letter is an X, a Y, or a Z? Well, what I can do is I can actually find the probability of X, which is 1 out of 100. The probability of Y, which is 2 out of 100, and the probability of Z, which is 1 out of 100. Now, because these are mutually exclusive, which means they can't happen at the same time, if I want to find the probability of all 3 of these, all I really need to do is add them together. So the chance of me getting an X, a Y, or a Z is actually 4 out of 100, which I can simplify to 1 out of 25. Okay? You could apply that with any question. You could say, what's the chance of me getting an A, B, or C? And all I need to do is add up over here 9, 2, and 2, and I would get 13 out of 100. Okay? So because these are mutually exclusive events, the chance of me getting one of those 3, I just add up all 3 of their individual probabilities. All right, what about this one? If Casey draws 2 tiles with replacement. Now, the 2 tiles makes me think, oh, this is a compound event. 2 things are happening. And then with replacement makes me think, oh, it's an independent event because we're putting the tiles back after we draw them, so we're resetting into what it was normally. So what's the probability of drawing an I followed by a T? So what I'm going to do is I'm going to find the probability of I. Look at my chart. It's 9 out of 100. And then the probability of T. Now remember, it's an independent event because after I pulled the I, in theory, I put it back in the bag. So there's still 100 tiles for me to choose from. And there's 6 T's. Now, because these are compound events, what I do is I multiply the probability of each of these. So I get 9 times 6, I multiply the top, 54, 100 times 100, I should get 10,000 because I add up all the zeros. I can divide both of those by 2, and I will get, let's see, 27 out of 5,000. So you can see that when I have compound events out of a large probability to begin with, out of 100, when I want to pull a specific letter and then another specific letter, the chance of that happening is quite slim. So again, this is theoretical probability. In theory, if I were to do this 5,000 times where I pull 2 in a row, only 27 out of 5,000 would I get an I and then a T in theory. All right, let's go on to letter C. Now we have Casey drawing 2 tiles. Again, compound event, but Casey is not replacing them. The tile does not go back in the bag. So what's the probability of an M followed by a G? So let's do my probability of M is 2 out of 100. But now I have not put that M tile back in the bag. So now there's actually only 99 tiles left. Okay, it went down by 1. And 3 of those tiles are G. So again, I multiply. Okay, so I get 2 times 3 is 6. And then I get 99 times 100 is 9,900. I should be able to simplify by dividing by 6. Remember, you are allowed to use your calculator for this one because I want you to focus on the probability. And we get 1 out of 1,650. That's your chance of pulling an M and then a G because we didn't replace the G. So actually, because we haven't replaced it, and the probability of this happening has gone up a bit. Okay, last one. Now Casey is drawing 3 tiles with replacement. Okay, so because she's drawing 3 tiles, or he, depending on who you know as a Casey, it's still a compound event. And we have replacement. So every single time it's being reset. Actually, let's solve this problem in 2 ways. Let's pretend that we're going to solve the first part with replacement and the second part without, just so we can compare it. So the probability of a C, then an A, and then a T. So the probability of a C is 2 out of 100 times the probability of an A, which is 9 out of 100. And then the probability of a T, which is 6 out of 100. Sorry, that should be multiplication. Oops. 6 out of 100. So I multiply 2 times 9 times 6. 2 times 9 times 6. And I get 108. And then 100 times 100 times 100. You can add up all the zeros. And you get 1 million, okay? So again, the more events that we add to our compound event, the lower the probability is. So in order for these 3 things to happen, it would only happen 108 times out of 1 million. So if we wanted, we could simplify that. We could do, it's 54 out of 500,000. And we can simplify that again to 27 out of 250,000 times. But now let's pretend underneath this line here that Casey is not replacing. So then we would get 2 out of 100 times 9 out of 99 times 6 out of 98 because 2 tiles are missing. So we'd still have 108 on top, but now the bottom would be 100 times 99 times 98 would be 970,200. I could simplify, but what I want you to see is that you actually have a better probability of it happening when you don't replace because your bottom number is smaller. Okay, so for your actual lesson, you're working through examples with the game of Clue. So really think about, is this a compound event or is it mutually exclusive? Then if it is compound, think about if it's independent or dependent. And then feel free to chat with me or call me if you have any questions. I hope you have a great day.